Hello everyone. This is the Interpretable Matching for Causal Inference project, and I'm Haoning Jiang. So, a summary. So, basically, the Almost Matching Exactly team had created an algorithm, Flame, that creates matches on given data sets. So, they've created Python and R packages for this algorithm. So, I extended the use of these packages by building a Stata package and by building a GUI. So these are the almost matching exactly team members. They've helped me a lot, and I'm very grateful. So first, before I could implement any packages, I had to understand the concepts behind the algorithm. So I'll start by explaining those. So first, the idea of causal inference. Causal inference is basically an attempt to see whether something is being caused by something else. It's useful, so it's useful in studies of medical treatment to see if your treatment is working. So one problem here is that you can only see one result per subject or unit. So if you give a subject your treatment, you have no way of knowing what would happen if they didn't receive the treatment. So it can be a bit difficult to tell if your treatment's actually working. So one solution to this problem is to match each unit with an identical control unit, give one the treatment, and then observe what happens. So that's basically the idea of matching, that you would match each treatment unit to an identical control unit. However, there aren't that many quote unquote identical twins in nature, so you need matches that are similar in just the relevant areas. By relevant areas, I mean that if you're testing, say, a medical treatment, you would collect a lot of data or covariates about the people or the subjects you're testing on. So there are relevant covariates, but there are also not so relevant covariates. So you would want to match on only the relevant covariates and exclude the irrelevant covariates. So therefore, like a good algorithm has to match on the correct covariates, know which ones to drop. So, so an algorithm that creates matches has two goals. It has to be matches have to be high quality, meaning that they're well matched on the relevant covariates and that they did drop the not so relevant covariates, and it also has to be interpretable, meaning the user can understand why certain covariates were dropped. So then once you make those matches, then you can look at the treatment effect estimators to determine like how effective your treatment is. So the Flame algorithm that this group created, basically it takes in a data set and then it creates matches on those data sets using the covariates in the data set. So basically how it does this is first it matches any units that can be matched on all covariates, then it finds the worst covariate to match on using machine learning and it drops that covariate, and then it matches any units that have identical values to the remaining covariates, and it repeats until the remaining covariates can no longer predict the outcome well. So first let me show you what an input and an output would look like. So typically an inputted like data set would look something like this, where you have units 0, 1, 2, 3 in covariates x1, x2, x3, and x4, as well as them all having a treated or value that's either 0 or 1 and an outcome. And then the matches would print out in a table like this, where the table shows you which covariates the units were matched on or were not matched on, and so this can be a bit difficult to understand. So I'm going to explain to you in more detail how the algorithm works. So first, in iteration 1, we start with the inputted data set, and then the algorithm looks for exact matches in all these units. However, no units can be matched exactly on all the covariates right now because no two units have the exact same values for all 4 of the covariates with another unit. So yeah, there are no matches made. And the algorithm learns that x1 is the least useful for predicting outcomes, so x1 is dropped. Then in iteration 2, after x1 is dropped, now we can make matches. We can match unit 0 and unit 3 because they have the same x2, x3, and x4 value. And after that, then x2 is the least useful in predicting outcomes, so it's dropped. And then after that, now unit 2 can be matched with unit 0, since for both of them, then x3 equals 1 and x4 also equals 1. Note that x2 and x3 are not matched because the goal here is to match treatment and control variables. I mean, treatment and control units, and there's no point in matching 2 treatment units. So now we've matched 3 of the 4 units, so there are no more covariate sets to consider dropping, and we are done. So that's how we end up with this table here. So now I'll explain the treatment effect estimators, which are basically measures of the efficiency of your treatment. You have the average treatment effect and the conditional average treatment effect. So first, the average treatment effect is basically the average difference between the potential outcome for a specific unit if it was treated, and the potential outcome for the same unit if it was not treated. And this is the average for all of the units. So let's look at our example here. This is the outputted table for the after the algorithm was run, and our algorithm told us that the ATE was 2.0. So basically, since the matches here are with 0 and 3, and also 0 and 2. So since units 0 and 3 were matched, they can be considered to be describing alternate potential outcomes for the same individual, and the same can be said for units 0 and 2. So in both cases, then the treated outcome is 7, and then the non-treated outcome is 5. So in both cases, 7 minus 5 is 2, and the average of 2 and 2 is 2, so the ATE is 2. The conditional average treatment effect is basically the ATE conditional on specific covariates. So in this case, you would take a unit and then find its main matched group, which is all the units that match with it, and then your average treatment effect would be conditional on these covariates. So then for this example here, then the average treatment effect here would be conditional on x2, x3, x4 all equaling 1. So in this case, then units 0 and 3 are matched, so that meaning they can be considered to be describing alternate potential outcomes for the same individual. So in here, once again, then the treated outcome is 7, the non-treated outcome is 5, 7 minus 5 is 2, and there's no other matches, so the K is 2. So now I'll discuss my implementations. So basically, I created first a Stata package, and then I created a GUI. So first, Stata. Stata is a statistical software package for data analysis and manipulation that's used by researchers in economics, political science, sociology, biomedicine, etc. Basically, a lot of fields. It's comparable to R, but there are some differences. So now I'll show you my Stata demo. Okay, so this is Stata. First, I'll show you what data I have input. What data I will be using. This is basically the same as the example in the presentation. So to run a program in Stata, you basically first type in the program name, and then you type in all the parameters in the correct order. So now it's created the matches, and it's given us the ATE and the ATT, but where are the matches? They're stored here in the estimation matrix area. So if we look at then eResult, then we can see these are the general matches. And you can see that these are the same as they were in the presentation. So I created some other variables as well. So Kate's is basically just the Kate value for each individual unit's main matched group. So as you can recall from the presentation, those were all 2, except for the indices are here off by 1, but then for unit 1 here, it did not have any matches, so no Kate value. Also then I also created another variable, which is weights here for people who want to do regression or similar analyses. So basically for treatment units, then weights would equal 1, and then for all other units, then weights would equal the number of treatment units that the unit in question matched with. So yes, this is the Stata package. Let's go back to the presentation. So some challenges in progress. So basically creating the Stata package took up most of the time in this program, because before this I had no experience at all with Stata, so I had to learn the entire language from scratch. But it was definitely worth it, because now I'm familiar with Stata and its basics. So it will be very helpful for my own analyses in the future. I can also write Stata programs now. and I have a better grasp of Stata Python integration, which will also all be very useful for the future. So now I'll transition to talking about the GUI that I created. Basically, the GUI is for a different audience than this data package. The GUI is basically for data analysts who are unfamiliar with coding. So it would give them a way to use the algorithm without having to know Python or Stata. So therefore, the goal is to be as user-friendly as possible, so it's accessible to basically everyone. So an overview of the GUI creation process. So basically, I created it based on example code provided by a mentor. So Flask was used to build the GUI and implement the Python package of Flame, and SQL Alchemy was used to handle the user inputted data. Now let me demonstrate the GUI. So basically, this is what it looks like on beginning. So you would upload your data here, and in a form of CSV file, and then once you upload it, then your inputted data sets will show up under here. You click on the one you want. You can click View to see what it looks like, and then afterwards, you can choose your treatment and your outcome variables here, and you can also choose variables to exclude from matching, which means that if they're checked, then they will not be used in the matching at all. So they start out all checked, you have to uncheck them. So the algorithm requires that the treatment unit is either 0 or 1 in order for the program to run. However, like if that's not true in your data set, you can have the data cleaned before any matching is done by typing in the condition that would make treatment equal 1. So say, for example, that you want like all the treatment values greater than 3 to be equal to 1 and everything else to be equal to 0. So in that case, you would type x is greater than 3 to show that you want the treatment greater than 3 to be 1, and then everything less than or equal to 1 will be 0, and everything greater than or equal to greater than 3 will be 1, and everything less than or equal to 3 will be 0 for the treatment unit. So we also have quite a wide variety of advanced settings that you can further customize how your data is matched, and the details of this can be found by this link here, which will take you to the group's documentation page. So now let's match. So basically, as you can see here, we get the end result. We get the general match result that you've seen in the presentation already. And you get the ATE here as well. And for specific match group for specific units, you can put in the index here and then see what their match groups are. So here, remember, for unit 0 matched with unit 3 on x2, x3, and x4. And then unit 2 matched with 2 and 3 only on x3 and x4. And then unit 1 did not have any matches. Let's go back to the presentation. So some challenges in progress. So I also did not have much experience in front-end development, so I had to ask a lot of other people for help. I'm very grateful for all their assistance. And I initially also had the difficulty getting the match results function to work, but eventually, like with their help, I was able to get it to work. So this is all very much worth it because now I have a better understanding of front-end development and the software I used. So in the future, after CS Plus ends, I intend to continue working on this project. So I intend to continue to improve what I've created. So for this data package, I want to return more variables or quantities that would make it easier for the data analyst using my package to get what they want out of the matches. So, and for the GUI, I want to make it even more user-friendly, and to do that, I want to implement some ideas such as like implementing a way to see like graphs or some visualization to help visualize basically the efficiency of the matches and the treatment effects and all that. And also, I want to add a way for the user to see the step-by-step breakdown of the Flame function and how it works. I'd also want the user to download the match results. That is all. Thank you very much for your time.